In today's video we're gonna talk about overhangs and about custom supports that you can create in Meshmixer to make them printable. As you probably know, FDM 3D printers extrude melted plastic and there has to be something to lay the new layer on, otherwise the plastic just drips and sticks to whatever it hits on the way down. So when you want to print really steep overhangs, or even parts that start in midair, you have to use supports. Most slicers use lattice or grid-like supports, and there is a really good reason for that. They're universal. It doesn't matter what kind or shape of the overhang the model has. With these supports, it will be printable. Yeah, you will waste some filament on them, and they do increase the print time, but it is a small price to pay for a successful print. Setting supports in Slicer is easy. You can pick whether to generate them everywhere or from build plate only, and you can easily decrease the amount of support generated by adjusting the overhang threshold. The lower you'll set the overhang threshold, the less supports will be generated. But in some cases, especially if there are just a few areas that need supports, you can get away with a different kind of support structure, and that's tree-like support. You can generate them in Meshmixer, and their main advantage is that they usually use less filament, so less wasted material. Also, it decreases the print time a little bit. But more importantly, you can customize where the support will be generated. You can click and drag to create a new support strat, and you can delete the supports where you know that they're not necessary, by holding down the Ctrl key and clicking on them. The tree supports come with one major disadvantage, and that's when supporting overhanging, flat areas. Each arm of the growing tree structure always supports only one point on the overhanging surface. So when printing a model like this, definitely stick with the normal grid supports in Slicer. Let's take a look at how to create the tree supports. Start by opening Meshmixer. Import your STL with the import button, or simply drag and drop it inside the Meshmixer window. Next, we have to position the model inside the print area. Turn on the virtual print bed by selecting it in the View menu, or by pressing Ctrl-Shift-P. In our case, the model is already positioned inside it. But if your model isn't, select Edit, Transform to adjust the position. This step is important because Meshmixer will only generate supports above the virtual print bed. So if part of your model is outside of the dark gray area, you won't be able to generate supports. Another thing that you can adjust in the transform window is the scale. If you plan to change the scale of the model, it's better to do it now, because changing it later in Slicer will also scale the supports. And that could lead to them being either too thin and weak, or too thick and hard to remove. Next, select Analysis, Overhangs. You can now turn the virtual print bed off to get a better view of your model from the underside. Areas that need to be supported are displayed with red highlight. The preview will update if you adjust the angle threshold. Meshmixer will attempt to support all highlighted areas during the computation. There are two submenus on the left that you can expand. We'll talk about these in a minute. You can start the computation of the tree support structure by hitting the Generate Supports button. This may take a while, but usually it finishes within seconds. When you change some of the settings, they won't apply to existing supports, but you can just remove all of the supports and generate them again. Let's get into the individual settings. We already talked about the angle threshold. The contact all sets the tolerance for detecting whether a part of the model sits on the ground plane, and chances are you won't ever have to change it. The Y offset pushes the whole model upwards and generates supports under it. This is really useful if your model has no flat area to sit on the print bed, but in our case it doesn't make much sense to use it. Next, you can set the maximum angle at which each support strut can climb upwards. If you set this value too low, the supports will likely fail to print at such a steep angle. And if you set this angle very high, Meshmixer may fail to calculate the supports properly. In general, values around 45 degrees or slightly higher work well. The density sets the spacing between the individual supports. The higher you'll set the value, the smaller the spacing will be. The default value of 75 works pretty well. You should set the layer height to the same value as your planned layer height in Slicer, but it's not the end of the world if you change it afterwards, or even if you plan to use the variable layer height function. The post diameter is pretty self-explanatory. Higher values will make the post really thick, small values thin. The tip diameter sets the width of the connection to the model. We found that values similar to the nozzle diameter work best, so usually around 0.4 mm. And the base diameter sets the width of the connection to the ground plane. Choose values around 6 to 10 mm. From the advanced settings, the most important one is whether you allow top connections or not. When you allow them, support struts may begin growing not just from the print bed, but also from the model itself. And last but not least, the Convert to Solid button lets you separate the geometry of the supports from the model, so that you can export it as STL. This is handy because you can then load the supports into Slicer and have different slicing settings for the model and for the supports. In Slicer, first load the model itself. Double-click on it and select Load Part. Select the STL with the supports. You can then change the settings for the tree support. For example, you can change to use no infill, only perimeters, without affecting the slicing of the model. Removal of the support structure should be easy with just your bare hands, but you can always use the pliers supplied with your printer. Check our blog for more information about tree supports and consider subscribing if you haven't already.